Hi, it is time for a trig overview with over B. Haha. Okay, here's the goal here. I'm going to run through this as quickly as I can, try to make it a 10-minute review. If you need to slow down on any of the slides, do so. Okay, first we started with angles, and we know we have an initial side, a terminal side, and where they meet as a vertex, initial side is always in this position. This angle is in standard position. Angles can move in two different directions. The terminal side can open up counterclockwise, right? Open up, and that would be a positive angle, or if the terminal side opened down, that would be a negative angle. So we have quadrants, right? First, second, third, fourth. Determining where an angle lies in which quadrant is a little game, like 170. Well, that's a little less than 180, and we know 180 is all the way over. So bloop, it's just up a little bit in the second quadrant. Same thing here, negative 330, we know, well, if we went negative 360, we'd be here. If we backed it up 30, we would still be in the first quadrant. So, and then of course, same thing with the radians. Let's get a little bit harder, right? 3 pi over 4, if you think of, if your terminal side opens all the way to here, that's pi. So if it opens 3/4 of the way to pi, you're going to be here in the second quadrant. And then 2 pi over 5, 2 over 5, that's a little less than a half, and you can do that on your calculator, right? So it's a little less than half of a pi, and we know that pi over 2, half a pi is right up here. So it'd be a little less, and it'd be in the first quadrant. Okay, so we're talking about coterminal angles, and with coterminal angles, that just means that angles that share the same terminal side. So here you see that we could open up our terminal side to a 45-degree angle, and that would look the same as if we went all the way around again and had a 405-degree angle. So yes, is there a difference between 405 degrees and 45 degrees? Absolutely. But when we sketch that angle on the XY coordinate plane, it looks the same, right? Except for these little hoopity-doops. So 45 and 405 would be coterminal because they share the same terminal side. And then we could go a negative direction, right? We could go up to 45 and then subtract 360, and that would leave us with negative 315. All right, and so there we go. We talked about that. To find coterminal angles, one positive and one negative, we would take an angle and add 360 to get the positive. We'd subtract 360 to get the negative. Sometimes we've seen this where maybe the angle is a negative angle, and to get a positive coterminal, we may have to add 360 twice to get up to that positive one. Or maybe in this case, like it's a negative 330. Well, when we added 360, we got to a positive angle. We had to add well, no, this is actually good, so ignore what I just said. I don't even see where that, remember when we were in that lesson, we had to add 360 or add 2 pi more than once. Same thing with the 3 pi over 4 and the 2 pi over 5. We're just going to find the coterminal. We add 2 pi, we subtract 2 pi. Don't worry, you can do this in your calculator, which you will have for your test. And then here, here's what I was talking about, right? The first time we took 13 pi over 6, when we subtracted 2 pi, we got pi over 6. And it's like, well, that's not negative. So we had to take pi over 6 and subtract another 2 pi from that to finally get our negative. And so sketching, once again, we talked about how to compare the 13 pi over 6. We're like, well, if we did that in our calculator, 13 pi divided by 6, we get 2 point something pi, right? And we know if all the way around to here is 2 pi, then 2 point something pi, a little bit more, right? Gets us in that first quadrant. Okay, so supplement are when two angles add up to equal 180 degrees or pi. And so if they give us an angle that's in radian mode, we're going to say, okay, 5 pi plus 12 plus some angle is going to equal pi. And we would subtract that 5 pi over 12 from both sides to get our answer. The complement, remember if someone says, oh, you look great in that color, you're like, right? Because complement, those two angles that are complementary, right, they add up to 90 degrees. 90 degrees is a right angle, so try to remember it that way. Same process of finding that. So on the test, so far, everything we've done, make sure you understand. And so unit circle, yay. Know the unit circle, because if you know it, you can use it, and that's going to help you. Using unit circle, how do you do it? Well, see how the unit circle, we have those coordinate points, which, oh, look, I picked a unit circle here that does not have the coordinate points. Okay, that was not well done. Let's quickly add a coordinate point. Like for 30, we'd have what? Root 3. Oh, really hard to write with my finger. My smartboard is out. So we have root 3 over 2, comma, 1/2. So when I say know the unit circle, I really meant that unit circle with the coordinate points in it. So you know what I'm talking about. Okay, that's a 2 underneath. Anyway, so in the unit circle, all the angles, like 30 degrees, we'd see this coordinate point of root 3 over 2, comma, 1/2. And what does that mean? Well, what that means is that whatever x is equal to, that's what cosine of that angle is equal to. So when we go back here, we're like, oh, cosine of 30 degrees, or cosine of pi over 6, is equal to root 3 over 2. Whereas sine of 30, or sine of pi over 6, is equal to 1/2. And so we can use that knowledge and know that we know cosine and secant, right? They're flips of each other, they're reciprocals. So that's how that works. And same with sine and cosecant, they flip. And we know tan is sine over cosine, which is y over x. And cotan's the flip, so x over y. Which leads us to me pushing something I shouldn't have. Okay, which leads us to this. On WebAssign and possibly on the test, you'll see something like this where it is the unit circle, but they picked an angle theta that's not one of our unit circle angles. So it's, you know, it looks like maybe 65 instead of 60, right? And so it's saying, well, don't worry, we're going to give you the coordinate points and use these to find sine, cosine, and tan. And so we're going to use this knowledge right here to fill in these answers. Okay, so that brings us to the trig identities, which we already used to understand how to use the unit circle. We had to know the trig identities. You have to have these memorized. All right, so remember who matches up. Remember sine and cosecant match up because S and C don't match up. And that makes sense because they're the flips of each other, the reciprocals. And then cosine and S, see the C and the S don't match up because they're flips of each other. Remember these, and remember secant, cosecant cot. So all of this slide you've got to have memorized. And then right triangle trig is based on SOHCAHTOA. And so if sine is opposite over hypotenuse, it makes sense that cosecant is hypotenuse over opposite. If cosine is adjacent over hypotenuse, secant's the flip, hypotenuse over adjacent. And if tan's opposite over adjacent, then cotan's the flip, adjacent over opposite. And that's, we have to memorize this, right? We use this all the time, especially on the test. So you'll see something like this on the test, just like you did with WebAssign, where there's a triangle, and they're asking us to find all the 6 trig functions of this angle theta. We don't know what theta is. We don't care. We're actually looking for what is the sine of that angle and the cosine of that angle. So first, we had to find that the missing side was 4, right? We used the Pythagorean theorem to find the missing side's 4. And then we're just using SOHCAHTOA and our knowledge of which trig functions are flipped, and off we go. So I'm going to hold on. I'm going to pause for 1 second. Okay, I'm back. So whether a trig function is positive or negative depends on what quadrant the angle is located in. But points in here, to get here, it had to move positively and up positively, right? Second quadrant had to move negatively and then up. So this is where what these signs mean. And of course, we know who matches up with x, who matches up with y. And so use that when we do problems like this. So you'll see something like this on the test and on WebAssign, where clearly this is not a unit circle angle, because look at this coordinate point. Our coordinates can't be bigger than 1. Okay, so we've got a 24 and we got a -7. So the first thing we've got to do is realize we've got to use right triangle trig. So we're going to make our triangle. Note I made my triangle and then flipped it up and took it off the xy coordinate plane, and then I used Pythagorean theorem, or I knew my triples, right, 7, 24, 25. The second thing I had to do is remind myself that it's in the fourth quadrant. See how the terminal side's in the fourth quadrant? So in the fourth quadrant, x is positive, y is negative, which means cosine would be positive, secant's positive, sine's negative, cosecant's negative, tan would be negative, and cotan's negative. And so with that information, we can go ahead and find everything, because with right triangle trig, we're going to use SOHCAHTOA. And then after we use SOHCAHTOA, we come back to put the negatives in, because we're in that fourth quadrant where sine is negative. And if sine's negative, then cosecant's negative, tan's negative, and then cotan's negative. Okay, you'll see something like this on WebAssign. I think you'll see something similar on the test. Find the values of six trig functions of theta. So they're telling you that cosecant theta equals 6. And that looks weird because we're used to SOHCAHTOA. So whenever we see something like 6, we're going to change it to 6 over 1. So then we have, cosecant is the flip of sine. If sine's opposite over hypotenuse, cosecant's hypotenuse over opposite. And so we can go ahead and say, okay, hypotenuse is 6, opposite's 1. We can use Pythagorean theorem to get that square root of 35. And then we have to know which quadrant are we in. So they tell us that cotan is less than 0, which means cotan's negative. So cotan's negative here, and cotan's negative here, right, in the second and the fourth quadrant. But we know that cosecant is positive. Oops, this says cotan, doesn't it? It should say cosecant. So let me go back and fix that real quick. So, whoops, let's make those be open. But we know that cosecant is positive, right? Because cosecant is equal to 6, and that's positive. So cosecant's positive, so what that means is that that only happens in the first and the second quadrant. So cosecant being positive, let's do this again. Sorry, I didn't finish this slide. So cosecant being positive only happens in the first and the second. And so where are both true? Where is cotan negative and cosecant positive? In this second quadrant. So we know that we are dealing with an angle whose terminal side is the second quadrant. And that's helpful, right? Because in the second quadrant, we've got what? To get there, we had to go negative for x and positive for y. And that means once we're done using SOHCAHTOA, we go back and we realize cosine's negative, secant's negative, tan's negative, cotan's negative. And so there are our answers. Let's move this. Okay, let me get rid of that. Okay, let's move it. Okay, so I'm trying to not run over 10 minutes. I think that I am sorry. All right, but we're almost done. Let's keep going. Okay, so you're definitely going to see something like this on the test. So make sure you understand how to do this. They tell us that tan of a theta, tan theta is undefined, and we're in a constraint, so we're only between pi and 2 pi. So let's break this down. First of all, where is tan undefined? Let's think about that. If we look at the identities, remember tan is sine over cosine. So the only way tan could be undefined would be when cosine is equal to 0. So anywhere that cosine is equal to 0, tan will be undefined. And cosine of theta is equal to 0, both at pi over 2 and 3 pi over 2. All right, so we're like, wait, if it's pi over 2 or 3, how can we tell which one it is? We go back to the constraints here. So they say it clearly. The constraints are the angle theta has to be between pi and 2 pi. Well, pi over 2 is not. Pi over 2 is less than pi, so it's not going to fall in this constraint or these boundaries. So we know 3 pi over 2 is where we're talking about. All right, that was a lot. If you need to slow that down and repeat it, oops, there it is. Wait, which one is it? Look at our constraint. Only 3 pi over 2 will work. And so we know that we're looking at the terminal side. Let's write this angle down. Let's get a good. All right, I'm without my smartboard, so I'm having to draw with my finger. All right, so the initial side's there, the terminal side's there. And at that point, we've got the coordinate 0, -1, which means that cosine 0, sine's -1. So we're going to use that to fill in these answers. So make sure you understand that. If you don't, talk about it with me. This is, for some reason, something that people find hard on the test. All right, I think that was it. All right, thanks for joining me. See ya.